Alright, so for example 3, we have two positive integers that have a product of 196, and we want to find the integers such that their sum is a minimum. Okay, so we have two positive integers. So two positive integers, we could call x to be our first positive integer. And then we could say y could be our second positive integer. So it says two positive integers, so x and y, because that's what we're calling them, have a product of 196. So product means you multiply. So we know that x times y equals 196. We want to find the integers such that their sum is a minimum. So we're trying to find the integers, so we want to know what x equals and we want to know what y equals, so that the sum is a minimum. Okay. So we were trying to find when x plus y is a minimum, because that's going to be their sum. Now, in order to type in something in the calculator to graph it, you have to only have one variable. So I'm going to put everything where we just have x's. So what we're going to need to do here is we're going to need to solve for y. This way we'll only have one variable. So if I solve for y here, y is going to be 196 over x. So that way, when I say my sum is x plus y, really the sum is x plus, and if we replace that y with the equation we just made, 196 over x. So this is the equation that we need to work with, x plus 196 over x. This is where we need to figure out where there's a minimum. Okay, so we're going to graph this. So if you'll pull up your calculator. Go to our y equals, clear it out. So we have x plus, I want to type this as a fraction, so if you hit math and go over to fraction, you can do the first one. So get you a fraction there, so 196 over x. You can go ahead and just hit graph, we'll see what happens, and we'll see what we need to change our window to. So right now I can't see anything. So I'm going to change I'm going to go to my window. I'm going to change my x max just to 50 because it was a little high. Let's just put 50 for our x max. And then, remember we had 50,000 last time. So let's just put, since it says 196, let's just put like 200. And remember, a lot of times you're just guessing here and you just graph and see if it works. So for my x max I put 50 and for my y max I put 200. Well, it looks like that will work. So there's our graph there. So let's draw us a picture. Now there actually is more to this graph, but this is the only part that we need. So we need to find that minimum in there. So we're going to do second trace minimum, which is number 3. Now on the left side, make sure you put it up pretty far over here. So left side, and then right side, put over here. So you're going to hit enter and enter again. So it's saying that that smallest point there is at 13.999, so we'll round that to 14. And then 28. Okay, so remember what this stands for. This first value is your x value, the 28 is your min here, not your max. Okay, so we want to find the integer, so it asks us to find x and y. Well, now we know x is 14. To get your y, you have this equation that we made. So to get y was 196 divided by 14, which is actually 14. So when x is 14 and when y is 14, the product of that, so we could double check our thing. So if we do, let's get out of our graph. We do 14 times 14, the product will be 196. And then it's saying when you add 14 plus 14, that will be the smallest sum that you would get if you had those two numbers. Okay, so for that one we were doing a minimum. Alright, for our next problem. So we have a farmer wants to build 4 equal pens for his pigs. The farmer has 1,000 feet of fence. What should be the dimension of each pen to maximize the area? So let's get us a picture here. So let's see. He wants to build 4 equal pens. Doesn't really say how they're located, but we'll say here. We'll say each of them has a length of X. And then we'll say each of them has height of Y. Okay, they could all be the same thing, but we're not sure. So I'm going to use X's and Y's. So 4 equal pens, if I made that, he has 1,000 feet of fence. So 1,000 feet of fence is talking about the perimeter. What should be the dimension of each pen to maximize the area? So we know the perimeter. We're going to have to come up with an area formula. Okay, so let's go ahead and think about area and what we're going to need for it. Because if we want to maximize area is what we're going to have to type in our calculator. So area of this. So for each box here, so one little pin here, the area of that would be X times Y. But we have 4 of those. So the area that we need is 4 times X times Y. But remember, we can't type this in the calculator if we have multiple variables. So we're going to need to use that information about the perimeter to be able to get rid of one of the variables. So the perimeter equals, if we write an equation. So if we do the perimeter for each part, so if we add up all these little parts here, all the x's, we have 8 x's. So it would be 8x plus, then we have 4 of the y's. So we have 5 of the y's. So 8x plus 5y. And we know that that perimeter is 1,000. So like the last problem, I'm going to solve this problem for y. That way I can put everything in terms of x's. So if I solve for y, I'm going to subtract over the 8x. And then I'm going to divide by 5. So here's my little equation for y. 1,000 minus 8x over 5. So now for my area formula that I need to maximize or put in the graph and find the maximum, I can replace, so 4 times x, and then instead of y, I'm going to put 1,000 minus 8x over 5. And this is what we need to find the maximum of. So we're going to graph this, and we're going to find the max. So if we pull up our calculator, clear out your y equals. So we have 4 times x times, let's make a fraction. And we didn't have to multiply anything out since we are just typing it in. Go ahead and graph and see what happens, and then we'll work on our x max and y max. So I can't see anything. So for my x max, it's at 50 right now. I'm going to change it to 100 just to be sure. But for my y max is only 200, and see how I have 1,000 there, and I have 4 and have 8. So let's make it big. Let's try like 5,000 and see what happens. Still can't really see, so it needs to be a lot bigger. So let's do like 50,000. Ooh, I can see the graph. So my x max I did 100, and my y max I did 50,000. So once again, you just have to make those bigger. Those are really the only two that you have to worry about making bigger normally. And just until your graph shows up. So if we sketch our graph, we have something like this going, and we need to find this max here. So we're going to do second trace max. Number 4. I'm going to move it to the left side, hit enter, move it to the right side, hit enter, and then guess and hit enter again. So it gives you 62.500 if we round, and then it gives you 25,000. So the 62.50, that is your X value. The 25,000 is your max value. It says, what should be the dimensions of each pin? So we really need X and we need Y. Well, X we said is 62.5. To get Y, we're going to plug into that formula that we made here. So we can just do that on the regular calculator part. So that should give us 100. So it said, what would be the dimension of each pin to maximize the area? So that would be 62.5 feet by 100 feet. That would be the dimensions of each pin for our 4 equal pins for the picks.